Hi guys, this video lecture recording for submitting seminar presentation on the topic of Indian knowledge system and geology for online refresher course in Indian knowledge system, which is held by the Malviya Mission Teacher Training Center HRDC, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar. Myself, Mohammad Javed Mohammad Noor. My roll number is 15. I am Assistant Professor in Geology, Department of Geology, Kohinoor Arts, Commerce and Science College, Khultabad, based Chhatrapati Sambhajinagar, Maharashtra. Guys, in our online refresher course, the eminent resource persons talked about the what is Indian knowledge system. In precisely, I want to explain it not much in detail, because in our ancient India we have in our Vedas, in our Puranas, we have the most relevant or most precise, or even today's science, relevant to today's science, that material we are having in our ancient knowledge. It's very vast actually. So in this seminar presentation, I am going to explain this presentation in three parts. The one is what is Indian knowledge system, and how is relevant with the geology. That's the second part. And in third part, what we are learning today in geology, and how is we relate or in our previous data or previous knowledge. Means I will explain in this three in detail. One, the pure Indian knowledge system, that's having its own merits, and the second one is the Indian knowledge system, a geology mentioned in the old our literature and traditions. And the second, what we are learning today is more relevant, or it's more means likely explained in our old literature. It's not different from that, or means it's explained in all on the basis of what data they have or what knowledge they have in the previous time. Means it's almost 3000 old year, or means old data, no? And this is when this is the current era, or we are correlating it. Means see the gap between, means it's 3000 year old data almost, and it's this time also they are looking very similar, looking somewhat the same. So further delay, I will start. Indian knowledge system is a generic phrase that encompasses the knowledge assets that have evolved in India. It includes mathematics, science and technology, medicine, astronomy, architecture, philosophy, arts, languages, literature, cultural and social practices, traditions, etc. Historically, Indian knowledge system has its own corpora, means it having its own written script or written books, in its own, and methods and criteria for generating, validating and propagating knowledge. In a simple language, IKS is about understanding our unique Indian perspective and approach on learning any subject such as mathematics, astronomy, chemistry, metallurgy, zoology, botany, geology, anatomy and physiology, pathology, physiotherapy, geography, knowledge of mines, mining geology, or my agriculture, economics, textile, philosophy, spirituality, yoga, psychology, Gurukula system of education, and so on and so on. The core pillar of Indian knowledge system are drishti means the perspective, parampara means the tradition, loki prayojanam means practical utility, skill, kaushal. Okay, the Indian perspective embodies the understanding of Indian culture, science, and values. Traditions refers to the transmission of ancient knowledge from one generation to generation, and practical utility involves the application of this knowledge according to local needs. This is the in simple format what is IKS is and what it want from us. Now it's need our uh, means traditions to be highlighted. It's want to be more realistic and practical to be what we are gaining and how we are implementing that knowledge in our daily life. uh, Means want to build a skill in through the knowledge or through the uh, with the its literature. Now, now how geology mentioned in the our old literature or ancient literature, that's the second part I am talking about. India was called as Jambudvip means island. Shape of is like a guava. Island means which is surrounded with the water. Okay, that is the island. Uh, Terrestrial land or a land which is surrounded by the water, it's called the island. Remember, that's the Jambudvip. Uh, I will explain it this one in later with uh, in just after a few slides. India has gigantic rivers such as Sindhu, Ganga, and Brahmaputra in the northern part, and Arabian Sea, Bay of Bengal, and Indian Ocean on the other side. Okay, the upper side we have the whole Himalaya, which having the Sindhu, Ganga, Brahmaputra uh, at the uh, at the upper side, and the below we have the right side, Bay of Bengal, and the below we have Arabian Sea, oceans, Indian Ocean. The next one, the ancient names for Arabia and Mesopotamia, Shalmali Dweep and Shak Dweep were respectively. Okay, ancient Indian sages means our Rishi Muni have described India as a Bharatvarsh or Bharatkhand as the land between Himalaya and Kanyakumari. See, at upper side we have Himalaya, the mountains, and bottom we have three-sided ocean or water. One side below the Indian Ocean, second side is the Arabian Ocean, and the right side the Bay of Bengal. Three-sided water we have three-sided, and the upper side is the Himalaya. In between this called the land called the Bharatvarsha or Bharatkhand by our Rishi. The land of India was formed in three different periods and under different geological conditions. These are the mentioned in the our ancient knowledge on that period. Now see the later. See this text in Sanskrit. Its mean this one explained in the Shilpa Ratna, volume 1, part A, volume 16. The country of Bharata is situated within the Himalaya mountains. That country is also divided into three parts by the characteristics of each country. The three modes of material nature, namely the three wheels and the three varnas, are mentioned in order. See, they are describing it on their way or by their understanding. The land of this Bharatvarsha present divided into three parts, like the upper one, the middle one, and the lower one. Now, the entire span was divided into four yugas, namely Treta Yuga, Krita Yuga, Dwapara Yuga, and Kali Yuga. Now, the modern geologists call these as primary, secondary, tertiary, and recent respectively, or Kinotic. I will explain it later. See the relevance. Now, the Krita Yuga is the period in which large geological transformation took place. The southern part of India was formed in this period. It never went underwater. See, it is one explained in that time. That Krita Yuga, what is that Krita Yuga? I will explain it in the next slide. In that time, the bottom area, it's southern India. Okay, in Sanskrit it's called the Dakshin. That's why we call the Deccan Plateau. Dakshin is changed. Sanskrit word change into the Deccan. Now the Dakshin is Deccan. So you maybe listen it Deccan terrain or that what it called the Deccan Express or other things. Okay, so in that time this land is never merged under the water. It's explained. Treta Yuga was the period in which mountains and hills were formed due to volcanic eruptions. See, in this period, Treta Yuga, the more volcanic eruption they are mentioning, it's happened. In that way, the land of Maharashtra and Vindhya region was developed in this period. Okay, in Treta Yuga. Dwapara Yuga was the period in which sedimentary rocks were formed. River basins of Sindhu, Ganges and Yamuna were formed in this period. See, the one is when the India is just started its journey. In geology it's called the continental drifting, and during this continental drifting means when the whole land was the one, it's called the Pangea, and after the breaking of that Pangea, that's also an explanation of different theory, but here just in a few words I am going to explain highlighting some points. After that journey started from west to east, that's called the Indian subcontinent. When it's joined together, that time they went the journey. That time this area, not the southern part, not merged under the not to merge under the water. Then after when it collided with the Eurasian plate, okay, collided with the Eurasian plate, that period is started, and when the mountains are built up, and that's after when the collision is means it's called the convergent moment. Due to convergent moment, the collision of the two continental plates, the mountains are built, that the Himalaya are made up of by this process, and due to that the land behind it means foreland area, at that place the volcanic eruptions are started. In that way the land of Maharashtra and Vindhya regions are formed. See the observation. Maybe this one how it is old or how much this one is old and how they observe, I will tell you later in the later section. Dwapara Yuga was the period in which the sedimentary rocks are formed, and the Sindhu, Ganges and Yamuna were formed in this period. See, when after the second step, the land going through the rivers and Ganga, Sindhus, all are going through the land, and they are forming the sedimentary rocks or deposits. They are mentioning at that time. Means Kali Yuga is the present period in which no major geological activities are occurring other than the volcanic eruptions or earthquakes. Now this recent times, or maybe in their recent times, they are not happening actively. Now see that periods try to correlate with the current geological periods. In English, if you say age, in Sanskrit it's termed as the yuga. Yuga means age. In age, of in our current era, head-on or Azoic or Proterozoic, in which the Earth started to form from the after the Big Bang. Um, that's called the head-on or Azoic or Proterozoic, means no life is present at that time. Related words are not yet found in the Sanskrit, but the primary, or it say the Archean or period, or no, so Precambrian period means the where the Paleozoic era and the Archean in between, that's the Krota Yuga. In that, the Ratna Chakra, precious stone, Hema Chakra means gold era, or Loh Chakra in iron. Maybe the similarity or correlation, some or little bit going up and down, but this relation I found. Okay, in this area these things are happened. Now the secondary era, iron era, or called the Mesozoic era. In that Paleozoic era, uh, means Cambrian, Devonian, Ordovician, Silurian. These parts of that Paleozoic era are present. Okay, but here in Krita Yuga they mention three, means somewhat logical they are related. In the Mesozoic era, that's that era is called for the dinosaurs. We know the Jurassic, Triassic, or those period, Triassic era. In these eras, the dinosaurs are present on the earth. That period was for the those gigantic animals. So that also mentioned in Treta Yuga. Now the tertiary or Cainozoic era means Dwapara Yuga, which is also means extended at the recent of Kali Yuga. Now listen, this Kali Yuga, no, this has no relation to Kali Yuga mentioned in the epic Mahabharata. That's Kali Yuga is different. This Kali Yuga is different. This Kali Yuga is a part of the geological time scale mentioned in the our old ancient literature. Now this the part of IKS have done the geology mentioned in the previous literature is done. Now this is the geology. What is geology and how the relation present in the Indian knowledge system? How can we relate? That I'm going to explain from here. Now, geology means Arthashastra, mentioned as Arthashastra, about the earth. Now, recently we call it as the Bhushastra or Bhugarbh Shastra, is the earliest Indian text dealing with the mineralogical characteristics of metallic ores and other mineral aggregate rocks. It recognizes ores in the earth, in rock, or in liquid form with excessive color, heaviness, and often strong smell and taste. See, the Arthashastra also mentions several subsidiary types of gems named after their color, luster, or place of origin. See, this one also I am going to explain. Means the upper one is they are recognizing the ores in the earth, in rocks, okay, in their liquid form also, in solid form also, and excessive color, heaviness, means by their physical properties, chemical properties also they are defining them, and by its subsidiary types like after mineral or ores they are defining gems by their color, luster, place. These are all the physical properties. I will explain this one in the next slide. So origin, the Vimalaka, Jyoti Rasaka, Lohitaka, Sasyaka, etc. These are the name of their origin. It is surprising that even in the first millennium BC, Indians had developed an elaborate terminology for different metals, minerals and alloys. See, they use these terminologies means for the metals, for minerals and alloys. Thus also I am going to explain it in the later section. But they are used this in the first millennium BC. Means almost 25,000 to 3,000 years back. Now if you ask a question yourself, if you look around us, okay, if you look around you, what will you see? Rocks, soil, planets, lightning stars, or like moon, sun, moon and star at the night, sun in the day. Hmm. Uh, and if you ask yourself from what they made up of, hmm, and how they are made up of, like if you hold iron, copper, gold, silver, um, construction material like cement and other things, you will see and you observe where they came from and how they made up of. The same thing maybe, same question maybe they having their self, okay. The same question they also asked by themselves and started to study them. So nowadays what you say about how you going to elaborate them? The basic thing is the minerals or ores or rocks you are saying about the earth, its smallest unit is called the mineral, okay. The all rocks, the all ores, everything is made up of minerals, and these minerals are made up of atoms or elements which are present in the periodic table. Now the thing is, these are all things formed due to inorganic processes. Now we are human having the organic life, but these organic life also originated from the inorganic processes. Due to inorganic processes in the previous time, that's also a history or a different theory. But this time I am going to explain just points, means about the minerals or geology. The whole thing is based on the minerals. So okay, so we going let's see what is mineral is. Means to who you call a mineral, okay. Now a mineral is a substance or chemical compound that is crystalline normally that is crystalline, and that has been formed as a result of geological process. The branch of geology in which the study of mineral is carried out is called a mineralogy. If you study the mineral, if you are studying the mineral, means is physical. I'm going to explain it. If you are studying the mineral, the branch of geology deals with the mineral is called the mineralogy, okay, in which all the descriptive, physical, chemical, optical, all its property are studied and mentioned in the top, branch of the mineralogy. Now, if you see the substance or chemical compound that is normally crystalline in nature. Crystalline means it should be solid in nature and formed by the geological process, means the inorganic way, by the inorganic processes. What the exception is, I am going to explain it now. Now, by the definition, a naturally and inorganically occurring substance that is solid with exception of mercury and water. Okay, these two are exceptional thing. The water maybe get into the solid after low temperature, but the mercury, if you mixed with the mica and rub it, then it's going to be solid. But in naturally, they are formed with the inorganic process, but at the normal temperature they both are found in the liquid form. That's the exception of the nature. So accepting these two, naturally and inorganically occurring substances that is solid, stable at room temperature, has definite physical properties and specific chemical composition, but that chemical composition is not necessarily fixed, can be represented by a chemical formula and has an ordered atomic structure. If there is no chemical fixed necessarily, but it should be represented by a chemical formula and has an ordered atomic structure. That ordered atomic structure means the internal binding of the atoms, how the clean or neatly they are binded together, and that internal bonding makes its outer surface, outer shape. That's I'm going to explain it. Minerals possess a set of constant properties. Now, these minerals which are having formed by the naturally process at one place, and that same natural processes or natural environment it got into the another place. So and then same chemical formula, the, the more possibility they will form the same compound or same mineral at that time on that place also. Okay, this is the property that particular mineral having its own, that is distinctive or its self character, that's own characteristics which distinguish it from other minerals. That's why the one mineral is distinguishes or different from the other one. Now, by the identification, these minerals can be identified by their properties such as physical properties, optical properties, and chemical properties. Okay, we look one by one these three properties. First one is the physical properties, then the optical properties, the chemical properties. Okay, there are also the miscellaneous properties also there. How to by defining the minerals means in some cases you finding the mineral, you found the mineral and the physical properties is enough to identify naming it or distinguish it, but sometimes these physical properties are not enough to distinguish it from other minerals. That's why we have to go with the optical properties. Means for our the deep study we have to go with the optical properties. Optical properties means the mineral we are having, we make it into thin section, cut into thin section, thin slice, and took it into the under the microscope, that's called the petrological microscope, and we studied under the polarized light, not ordinary light. That's why the petrological microscope are somewhat different than the biological microscope. In that cases you need just an ordinary light to observe them, but for the minerals you need an specialized microscope, that's called the optical microscope. In that you are observing under the light which are transmitted and reflected. The both you can do in the that petrological microscope. So you can observe doing this, you are going to observe the thin section properly or effectively. Okay, that's called the optical properties. Those are I'm going to explain in the next slides. Now after that, okay, the chemical properties also important. Means the minerals, see in the slide you are seeing the minerals. By if you I'm going to ask you, is there any similarity or they are looking same or different? So definitely you are going to say other than the shape, means all are looking round, all are different. Okay, but these are not different except few ones. All are quartz geodes. Inside this the purple one, the white, red one, yellow one, and the other pink one, all are quartz. Just they are showing the color or because of impurity of the element or atom they are having. Okay, only that basis. Otherwise these all are same, are called the geoid. Okay, some impurity by the chemical composition of other minerals also get included in it, but all are one is amethyst, second is citrine, other one is the pink quartz, or those things, but all are quartz, varieties of quartz. Now just little description about going further. As of today there are about 4,900 known minerals species are present. Scientists are found, or geologists are found, mineralogists are found. With the progress of research, one or two elements are added every year. See, now over 2,000 minerals have been found in the Earth's crust, and only less than 10% or 10 accounts for over 90% of the Earth crust. See, the Earth crust contain almost 10 more 90% of the 10 elements are 90% constitute the Earth crust. That difference I'm going to explain in next slide. The most common Earth crust forming elements in decreasing order of their abundance are: more is oxygen, then silicon, aluminium, iron, calcium, sodium, potassium, magnesium, and the rest is constituted by elements like titanium, hydrogen, phosphorus, manganese, sulfur, carbon, nickel, and others. Okay, these are having almost the 90% of the earth crust. Hmm? The elements in the earth crust are rarely found exclusively but usually combined with other elements to make various substances. Of these, silicon and oxygen are the most abundant. See, these minerals natively found very rarely. They are found, but that the rare cases. But usually, silica, oxygen, and silica found abundantly. These two elements come together and form the compound they form. Are the most abundant element which combine to form the mineral silicate group known as silicates. See, oxygen and silica, uh, they come together and form this silicate group of minerals. We will see it later. Earth as a whole, by decreasing order I am writing here: iron, oxygen, silicon, magnesium, sulfur, nickel, uh, calcium, and aluminium. Now, that the earth as a whole, or the second one, the earth crust. In the earth crust, oxygen, silicon, iron, calcium, magnesium, sodium, and potassium. Now see this in the next slide. This is the earth crust, and this is the entire earth. Okay, don't confuse between these. Earth crust, the crust is almost from surface to 10 to 11 kilometer at the continental side, and 5 to 6 kilometer only on the ocean side. In that also, the crust divided into Sial and Sima. That's also a different task. But in the crust as a whole, oxygen is 47%, silicon is 28%, aluminum 8%, iron 5%, magnesium is only 4%, calcium is 2%, potassium 2%, sodium 2%, and others are 2% in the crust. Now, earth as a whole, iron is the more, 35%, oxygen 30%, silica 15%, magnesium 13, nickel 2%, sulfur 2, calcium 1, aluminum 1, and others are 1%. See, gold, silver you are going to find come under the titanium, platinum, radioactive elements, all are come under the others. Those are only 1% and less than that. Okay, next slide. Okay, now if you ask formation of minerals, how they form, the process that are responsible for the genesis of minerals are solidification, sublimation, recrystallization, evaporation, and precipitation. But what is this solidification? When the hot molten magma solidifies through cooling, it cool above the surface and it cool the below the surface. When the below the surface is cool, it produce the plutonic rocks. Above the surface produce the volcanic rocks. The volcanic rocks are solidifies very fast or very rapidly, so that's why they not having chance to produce the minerals. So those when the magma get crystallizes below the surface, when it's having time to produce or crystallize the minerals, during that period or during its upward journey, during upward journey, when it's have time to produce mineral in it, so diamond, ruby, sapphire, and these aquamarines are formed in the magma. Means in the magma forming the minerals are very, you know, very rare. Means that magma at the beginning having the most high temperature. Only few minerals like diamond and rubies, these are having the highest temperature for their melting points. So only these are stable at that temperature and form in the magma during the solidification of it. Okay. So next, the sublimation, wherein the gases for form of minerals are formed through evaporation and precipitation. Escaping gases are only about 2% of magma. Very little minerals are derived from it. However, sublimation is rather a rare process. Example, gypsum near dormant volcano, sulfur and pumice near active volcanoes, and sylvite. These are found around the volcanoes. Why? Because when the gases are released only in the possible during the volcanic eruptions. That's why near volcano, like dormant volcano, means it is erupted, but very very long time, or its chances very less to erupt suddenly. So that's volcano is called the dormant volcano. But the uh, gases released by their vents regularly, so around it these uh, gypsum uh, gypsum which having the means CaSO4 formula in its hydrated form, form around the vents, and the sulfur or pumice, yellow sulfur, you will see around it, which gets in some time when the light come on it, it shows up radioactivity, and you will just suddenly get यू नो डर जाते कि ये क्या देख ली, अचानक रोशनी दिख के बंद हो जाती, सडन लाइटनिंग एंड दे गेट स्टॉप्ड. Now the active volcanoes and the sylvite also, KCl, potassium chloride also, you will see. Now that is salt of the potassium. Now recrystallization, this also a process in which the minerals are formed, in which minerals are formed due to recrystallization during metamorphism. Due to change in temperature, pressure, and active fluids around, minerals rearrange their internal atomic structure during new and old atoms removed or exchanged. Example: sandstone to quartzite, limestone to marble. See, these are the rocks, but in sandstone you will see silica is the main dominant mineral, which get heated or during the crystallization is changed from sandstone to quartzite. That's the one is the sedimentary and second is the metamorphic type of rock. Now this limestone, the mineral composition is the same, but now the sandstone changed into quartzite. The second one is the limestone, or if you change Ca with the magnesium, then it's the dolostone. So limestone, when get heated, CaCO3, the dominant mineral is the calcite, change to marble. See the Taj Mahal, that's formed in the marble. So it is previously limestone, but when get temperature, pressure increases on it, is changed into marble. It's called the recrystallization, rearrangement. Now by evaporation and precipitation, wherein the materials dissolve in water, when the magma leaves the water, in that process crystallize on precipitation under suitable environmental conditions, like anhydrite, CaSO4, or gypsum when a water addition is there, and halite, NaCl. This NaCl means this halite or salt, you will see addition of other elements or other minerals, constituents or impurities. Sometime it's changed into rock salt or black salt, or in the other condition it's changed into the pink salt, means Sindhya namak, you locally call it. Now see the physical properties of minerals. Physical properties of minerals can be identified by inspection of handheld specimen in the field. Since minerals are composed of different elements, they certainly pose different physical properties. Furthermore, each property to a degree is diagnostic, and all minerals possesses some distinctive features that allow for their identification. This makes it necessary to understand and have a knowledge about all the possible physical properties that may help to identify and differentiate minerals, and they are as follows. See, by the distinguishing minerals, so we need to identify on the basis of their physical properties. So physical properties having some parameters on which the mineral can be identified and distinguished by their special properties. And physical properties, the parameters like its color, the main dominant, the you when you see the mineral first, the first thing is you come in front of your eyes, it's its color. So what is color? Color for some minerals becomes a diagnostic property and is produced due to transmission of or reflectance of light by it. In other words, the absorption of certain wavelength of light by atoms making up the crystal produce different colors of mineral that is seen on its surface by the naked eye. See the what's process going on when a mineral showing is a color means that color is due to reflectance or transmission of light through it. It's produced that color when certain kind of wavelength it's get absorbed other or other certain uh, one particular kind of wavelength is get reflected by due to that reflecting wavelength shows that particular color to the mineral. Okay, so you will see this directly with the naked eye. The true color of mineral is vitiated, identified. However, due to the presence of even minute quantities of impurities present in it, therefore one specimen of mineral may display gradation of color or different colors, making the color a general property rather than a specific property. See, very rare conditions, a mineral having purest form. Okay, the maximum time it's get impurities in it, so that's why the color also that much not that much believable or helpful for identifying the mineral. Some minerals display a fairly constant color. Example, galena. Galena always show the lead gray color, but for most mineral the color is variable. Like pure quartz is always transparent, but impurities may yield colors like pink, red, or black. Since the color is always observed by the naked eye, the name of the color may slightly vary from individual to individual. Hence, the color of the mineral shown in majority should be taken into consideration. See, these all are following are seeing the images are of the quartz. One is the transparent quartz, is a rock crystal, and the second was the same but the impurity of other mineral other element it's make it to blue, that is the titanium impurity make it look like impurity of blue color, give it to blue color, and that's called the amethyst. Okay, and the others are beside that. Now the second property is streak. Okay, streak, then luster, and these are the luster properties which called already lecture recorded 43 minutes, so it's not possible. I am having 28 slides. This one on current slide is 18, so just I am showing you slides and then I have to stop. Already 43 minutes are over. There is a fracture, a specific gravity, hardness, and then the optical properties. I told you I am going to explain it later. Optical properties under polarized light means light, not ordinary light. I am going to explain. The polarized light, when the light is passed through the polarizer only, analyzer or nickel prism is not inserted. The optical properties of mineral which can be studied are color, plagiarism, shape, cleavage, and relief. In optical properties, when you are observing optical properties, the ordinary light, which are mixture of or the what it called, it's vibrating in all direction. You have to change that all vibrations into one particular direction. That's called the optical light. Okay, optical properties in which a light with the help of polarizer, what it do, the polarizer do, it's reflect light come inside it to in one direction. Okay, means the direction of the light in which the uh, particles of light or quanta it's called in physics vibrating only one direction. Hmm? So that's the optical light through which we are going to see in thin section color, pleocrism means change in color, its shape means its, if it is pure, its sides are looking sharp and in shape, that's called the euhedral. If it is not, then unhedral, and in between it's called the uh, subhedra. Now the cleavage means direction of where from where it broke, and relief, okay, means the how much percent you rock the mineral in this section you are looking, and the background of it. The combination of both create refractive index that's show the relief means high low its relief is present under the microscope. The second one is when the light is passed through the polarizer and analyzer both at the time, and which is called the undercross nickel is inserted, the light is partially absorbed and reflected by the minerals. By this process, the optical properties like extinction angle, twinning, relief, birefringence, twinkling, interference figures, etc. we study. Okay, even in the polarized light, the vibration direction are going horizontal or vertical. So after inserting the nickel prism or analyzer, what you are doing, you are breaking it into two, one direction going only horizontal or second direction going only vertical. So if you rotate the screen, that thin section will come under the vertical vibration, it shows different properties, and when it come under the uh, horizontal vibration direction, it's called the ordinary light or extraordinary light. So it shows the different properties. These properties you are going to study under the optical properties. And the next one, the chemical formula. In the chemical properties you are going to study on the basis of chemical properties and the elements shown above. Most common silicate minerals are made up of chiefly of a few of the following 9 elements: sodium, potassium, aluminum, calcium, magnesium, iron, lithium, and silicon and oxygen, with some of other elements in traces. Okay, so I already shown this. The silica and oxygen make the silicate structures. That silicate structure is formed by after the X-ray fluorescence show silicon oxygen tetrahedra. In this structure you will you are seeing this, that's called the independent tetrahedra. Okay, and that independent hydra attached to one another means one tetrahedra is attached to another tetrahedra, it's called the double linked tetrahedra. That is also you are seeing in the figure. Now these two combined with the two, or that two combined with the one, that's called the create the complex linked tetrahedra. That's also show you are going to see in the figure. On this tetrahedra basis, you going to explain or you are going to verify the single tetrahedra and the double linked tetrahedra as described above may in themselves be repeated in space in a variety of ways, giving rise to different structural formulas. Now these chemical reactions produce different forms in the silicate minerals. Among these structural forms, the following are of common occurrences, like the sheet structure of mica, the mineral mica, and its mica is a group of minerals in which you will muscovite, biotite, phlogopite, and other mineral you will go study. All are having the same physical properties or same structure. Some are what different, but all are having the sheet structure due to their this complex linked tetrahedra structure. In some, the independent tetrahedra that create the network or network structure are called the tectoframework silicate. That's you will find in the feldspar group of minerals, in which uh, mm, albite, anorthite, um, mm, oligoclase, or all the feldspar group of minerals you will find. Um, show the same type of structure or tetraframework silicate in their structure. In the chain structure, this double, if you find this double tetrahedra linked to one another, and the binding material when the other elements like sodium, potassium, or other minerals bind this uh, double tetrahedra into chain like structure, when this chain is single, it produces pyroxenes. Means pyroxene showing the single chain tetrahedra structure in it. And if the vertical and horizontal binding elements are two, means this chain linked by another with the another link chain, then it's called the double tetrahedra linked chain. And that double chain of tetrahedra is called produce or amphibole group of minerals. Means all of the amphiboles having the double tetrahedra in their structure. Now, thank you. I am glad to be a participant of this online refresher course, and I hearty thanks for the organizing committee of this online lecture. Thank you.